Now the step number 6 is check the stresses in I. So from this design procedure of knuckle joint, we can refer this step number 6, that is check the stresses in I, and these are the three stresses that we have to check. First is the tensile stress, second is the shear stress, and third one is the crushing stress. And these are the corresponding equations for tensile stress, shear stress, and crushing stress. So now let us check the stresses in I one by one. So equation of tensile stress in the I is P upon B into d0 minus d. So now let us put the value of P, B, do and d, which we have already calculated. The value of P here, it is 100 into 10 raised to 3 Newton. Value of B is 53 mm. Value of do is 108 and value of small d is 54. Now if you calculate this, you will get the answer of 34.94 Newton per mm square, and this is the value of induced tensile stress. Now if you compare this value with the permissible tensile stress, it is 80, and thus we can say that the induced tensile stress is less than permissible tensile stress, that is 80 Newton per mm square, and therefore design of this I under tensile stress is safe. Now similarly check the second stress, that is shear stress. Now I have written here the equation of shear stress from this design procedure, and now if you look at these two equations, the RHS is same, so the answer also will be same. So now just for this formality, we will put this value of P, then this B, do and d, and let us write the same answer because RHS is same. So we will get the same answer of this calculation of RHS, but this is the induced shear stress in this I. And if you compare this value of induced shear stress with the permissible shear stress, the permissible shear stress for all parts including I is 60 Newton per mm square, and thus this induced shear stress is less than tau permissible, that is permissible shear stress, whose value is 60 Newton per mm square, and therefore we can say that the design of I under shear stress is safe. Now the third equation is crushing stress. From this design procedure we can refer. So induced crushing stress can be obtained using this equation sigma c is equal to P upon Bd that I have written here. Now let us put the value of P here. It is 100 into 10 raised to 3. Then B is 53 and D is 54. So here answer, if you calculate, you will get the answer as 33.94 Newton per mm square. Now in order to check the safety of this I under this crushing stress, let us compare this value with the permissible compressive stress, and the permissible compressive stress sigma c is 80 Newton per mm square, and thus we can say that this induced crushing stress is less than permissible compressive stress, which is having magnitude of 60 Newton per mm square, and therefore the design of this I under crushing stress is also safe. Now the last step is step number 7, check the stresses in fork. If you refer the design procedure of knuckle joint, you can find these three equations, that is first for tensile stress, second is for shear stress, and third is for crushing stress. So we have to check these stresses one by one. So let us write first tensile stress induced in the fork. Now this is the equation of tensile stress that we have written from this step number 7 of design procedure of knuckle joint. And now let us put the value of P, A, do and D. Now I have put the value of here P 100 into 10 raised to 3 Newton, then A is 32, then do is 108 and D is 54. If you calculate this answer, you will get the answer as 28.93 Newton per mm square. Now in order to comment about the safety of this fork under tensile stress, we have to compare this value of induced tensile stress with the permissible tensile stress, and the permissible tensile stress value is 80 Newton per mm square, and thus we can say that this induced tensile stress is less than sigma t permissible, and its value is 80 Newton per mm square, and therefore design of fork under tensile stress is safe. Now let us check the second stress, that is shear stress tau. Now I have written this equation from the design procedure, and that is from step number 7, that is the equation for shear stress in the fork. Now let us put the value of P, A, DO and D. As the RHS of this equation sigma t and this tau is same, so we will get the same answer of this RHS. So answer will be 28.93 Newton per mm square. Now in order to comment about the safety of this fork under this induced shear stress, we have to compare the value of this induced shear stress with the permissible shear stress, and the value of permissible shear stress is 60 Newton per mm square. Okay, so already we have used it for the I, so we can say that the induced shear stress is less than the permissible shear stress, that is tau permissible, and whose magnitude is 60 Newton per mm square, and therefore we can say that the design of this fork under shear stress is safe. Now let us check the last stress in the fork, that is crushing stress. Its equation is sigma c is equal to P upon twice AD, which I have used from the design procedure of knuckle joint by referring the step number 7. Okay, so this is the equation for crushing stress in the fork. Now let us put the value of P, A and D here. So I have put the value of here P 100 into 10 raised to 3, value of A as 32 and value of D as 54. If you calculate this, you will get the answer 28.93 Newton per mm square. If you compare this value of induced crushing stress with the permissible compressive stress, you can find that this induced crushing stress is less than permissible compressive stress, sigma c permissible, and the value of permissible compressive stress is 80 Newton per mm square. Okay, and as the induced crushing stress is less than permissible compressive stress, that is 80 Newton per mm square, the design of this fork under this crushing stress is also safe. Okay, so as you have got all the induced stresses less than all the corresponding permissible stresses, so therefore you have to write one statement as like this. So finally you have to write this statement, that is, as all the induced stresses, that is induced tensile stress, induced shear stress and induced crushing stress, are less than the corresponding permissible stresses, and therefore the design of I and fork is safe. Either you can write this similar statement separately for this I also, but if you write this statement combinedly for I and fork, it is also okay. So it is acceptable. Okay, so you have to write this statement. This statement is very important after step number 6 and step number 7.